Morty, we've got to turn the project in early.
Hey everyone, it is time to do some work. See if we got anyone in the chat. Starting up here. Stream is live. We're ready to go. Okay. People, we got a good bit of work. Let me send out a reminder and say, let's do the quiz. Let's see if we can get some people in the chat. Several rooms. Let's say, come by and do the quiz. Chapter 15 quiz. Complete. Yeah. Okay. What we got? Chapter 15 quiz. Okay. Let's see what the first question says. So these first two questions, we need to mark them in the notes here. They're easy ones. It's easy. We are just figuring out what the null hypothesis is, I think. So let's mark this. And fall to 3. And stat 201, chapter 15. A very large study. Now I know this one's super easy, but we have to learn the learning objectives. And the learning objectives for this one is the null has the equal sign. The null has the equal sign. So when you look at writing the null hypothesis, it has a few things that are key. One, we always put a population parameter first, then we put the equal sign, then the hypothesized value. So if you're writing down notes, there are 3 things that make up the null. A hypothesized value is on the far side, what you believe is true. The equals value is what we're saying we think it is. We think the truth is this. And the truth is something out of population. This question, which is in the notes, is about the percent of people who get blood clots after an open heart surgery, and we're asking, is the true percentage of people who get the blood clot 7%? So we're hypothesizing that it is 7%, then we're looking for evidence if it's greater than 7%. So to find the null, whatever we're testing, 44% of people is the hypothesized amount that we believe to be true for the proportion in the population. Next one right here, what are we writing a null? Easy stuff. Easy, lightweight. Oh man, is it gonna rain outside? Probably gonna rain. Stat 201, let me write this down. Oh, chapter 15 quiz. Takes more time to write the thing than to do it. Because we should know the null has the equal sign. The null has the equal sign. And since the null has the equal sign, you can easily know that they're claiming the true proportion is 1/4. So they're saying they think they're psychic and they can identify the suit of a card before you show it to them. Well, you would think that they would only have a 1/4 chance of getting right, and then you try to find evidence that is probably greater than 1/4, because if they're psychic and they're figuring it out. This is not the null, that is the alternative most likely, because the null is that they would get 1/4 right, because that's what's likely by random chance if you guess a card. So you would believe the true proportion of cards that they guess right, and I will say this, try to read that. The more you can read P as the true proportion and then say the context of the cards they would guess right, the more you'll understand the later parts where we have to do the hypothesis testing of this. So the true proportion of cards your friends should guess right is equal to 1/4. And the null has the equal sign. Quick and easy to do the null every time. Once again, we're doing the null hypothesis. These are all so quick and easy. We're just like doing a billion questions today. If you have a question, you can drop it in the chat. Drop any question at any time. Even if it's not 201, we'll change topics. And then someone will be like, where was the questions? They're like, oh, no, we didn't get 201. It's all right. Which of the following hypotheses? It has an appropriate... Well, we know our tricks. The null has the equal sign. They should be writing HO before that. The null is that the true proportion of whatever we're measuring is equal to 30%. Nice and easy. Which of these is not appropriate for the alternative? Now, this is nice. We're getting a little change of pace right here. Hey, Kaya, let's do the potato chip one. You got it. We'll do this not appropriate one for the alternative, and then we will do the potato chip one. Are you saying these questions are too easy? They are. I was going to do all the easy multiple choice ones. Which of the following? And there are 3 alternatives. The less than, the greater than, the does not equals to. If you go to our notes that we've been taking, we should have it as probably in the first set of notes we did today. We graphed out the less than, the greater than, the not equal to. So we should have done it at some points. I know we went through it. I have to go back to the drawing. Well, it's here. There's a does not equals to alternative where we graph both sides. Here's the, hey, Brando, good to see you. There's the less than alternative, and there's the greater than. So you can see the greater than, the less than. We're talking about this right here, the sign of the alternative. There are 3 of them, and they show which way you graph the curve or shade the curve. So the sign of the alternative picks which way you shade the curve. So very clearly, this is not an alternative. So we do not have the less than or equal to alternative. I think potato chips is around here. Oh, I literally clicked it. Wow.
Wow.
Okay, it's the potato chip question. Let's do this. Moira, good to see you there. Good to see you, Moira, in the chat. Help me out these questions. Moira, Kaya, and Brandon. Brando. Sorry, Brando. And let's do this. I was showing some in my office, and it was really neat. They do a lot of cool stuff, too. It's Tori Olson, who is going to be doing... he's gonna be doing some new stuff releasing, but he did the Red Dead class, and he signed my book, or the book for me and my wife. Really awesome they did that. And he got to go to Comic-Con. So really cool stuff. We got a lot of really awesome educators here at University of Tennessee. I mean, like, think about like your teacher being like, I wrote a book on Red Dead Redemption. I mean, I like Red Dead. I like books. I like Red Dead more than I like books. So that's just a cool book to write. Hence why I got it. And with this right here, let's do the potato chip question. So when you measure the amount of this weight, the first thing you want to think for these questions is weight. Yeah, I know, right? That's awesome, Moira. The first thing you're going to think about this with these variables is that weight is either categorical or quantitative. So help me out in the chat. Is weight categorical or quantitative? Is weight categorical or quantitative? What is weight? Is it I know it doesn't even ask that here. Is weight categorical or quantitative? Is it categorical or quantitative? So put cat or quant in the chat. Is the idea of weight of a potato chip? It's quantitative. It's quantitative. It's actual real numbers, right? So are we going to use P or mu for the null? For the null, are we going to use P, which is proportions, or mu, which is means? Which are we going to use for the null? Are we going to use P or mu? Because the test might not give you the hints. You have to be like, wait, are we doing stuff with quantitative data? Or are we doing stuff with categorical data? We're going to use mu. This is for categorical right here. The 1 proportion z test is for categorical because it's the proportion that meets a group. And then the test for the mean, well, the mean is quantitative. Literally means are quantitative. So the test for the mean is quantitative. So that means when you go down here, you're going to see mu. Remember the null has the equal sign? Boom. And we want to see, I think, is there a difference? Randomly select and test the hypothesis that the net weight is as claimed. So which alternative will we use? 1, 2, 3, or 4? We're trying to see if it is the weight that's it's claimed or not the weight that it's claimed. Is it 1, 2, 3, or 4? We're testing to see if it is the weight or it's not the weight. Which of these would we use? 1, 2, 3, or 4? We're testing to see if it is the weight or if it's not the weight. First, second, third, or fourth. We're seeing if it is the weight or is not the weight. What's going to be the alternative? Because this says the true mean weight of the potato chips bags. The null says the true mean weight of the potato chips bags is 28.3. So what's the alternative we'll use? Because we want to use, is it not that? It is the first. Because the does not equals is just saying it either is this or it's not this. The fourth one would be, oh, well, that's the null. That's the null. And we'll use the it is that claim or it's not that claim because they're asking, is it true that it is that weight? They're not asking, do they weigh more, do they weigh less? Now, the reason I did that first is that follows the methodology we generally use. The first thing we like to do when doing tests is to write out our hypothesis. So when you think about this right here, we write the hypothesis first. The true mean weight of the potato chips bags is equal to 28.3. The alternative is it's not equal to 28.3. Now we're going to check the conditions according to them. And to check the conditions, the independence condition, I hate that they do this, is possibly satisfied. This would be randomness right here, possibly. The nearly normal condition is possibly satisfied. And we should be using this, or because we can't use it, we shouldn't be doing this. Now, these are important to get. You can enter this into any online calculator or applet. We're going to do the work in Jump right here. Makes life really easy. Go to the little box right there, click it, and go to Copy to Clipboard. Click Control-C or Command-C. Now go inside of Jump. Inside of Jump, hit Control-N or go to File, New, Data Table. Command-N or Control-N, File, New, Data Table. And now hit Edit, Paste. And so now we have the data in Jump. You could also enter it in too if you want, but Paste will enter it. Make sure the data is not at the very top or you've pasted with column names and that's going to be a problem. It should look like this right here. Analyze, Distribution. Analyze, Distribution. Double click the variable. Click OK. Now we're going to click the top right arrow and click Stack. And we can run the test really easily. Do you see how the hypothesized value is 28.3? Well, let's just click right here and say, test the mean. When we click test the mean, it's going to ask us, what value do you hypothesize is true? That is mu naught. Mu naught is the hypothesized mean, and we are hypothesizing that 28.3 is true. And guess what? There's the p-value. Very important to know what this output means. The p-values are for the three alternatives. You only really use one of them. This is the weight of our potato chips, or our mean. This is our mean, our result. We are doing the does not equals alternative, so which alternative, which p-value are we going to use? The first, the second, or the third? Which p-value will we use? The first, the second, or the third? The first is there, the second, third. The top one, Moira is on fire. Moira knows the answers. Go to SI. Moira knows it all in a good way. It is the top one right there, because that is the does not equals shading both sides of the curve. The does not equals shade both sides. The less than shades to the left of that line, the greater than shades to the right. And it's actually not showing the less than, but it would be a whole lot of this curve shaded below that red line right there, because you just shade to the left for the less than. So the p-value is 0.0335. And we can go get the other info about the mean and the standard deviation, 28.76. And the standard deviation being, I like it, Brando's got all those points. Oh, you got the Moira level. Wait, is Moira at the Moira level? Oh, wait, that's just Moira's name. Cooking with Drew level. 0.39. 4 decimals. What's the other ones? 0.3932. Or 33, because it rounds. And the t statistic was, the output's going to tell us, 2.91. It's right where it says t. Sorry if that was a little quick. It's right where it says test statistic t. And the p-value was 0. Hey, Dylan, good to see you there. So this is where I want you to jump in. What do we do with an alpha of 0.1? What do we do with an alpha of 0.1? With an alpha of 0.1, our p-value is what to alpha? Our p-value right here of this is what to alpha? This is where I want you to jump in. And our p-value is what to alpha? Our p-value is what to alpha? Well, think. Is it above or below? Our p-value is what to alpha? That's all right. Say goodbye to the null. And Moira's got it right there because the p-value is less than alpha. Remember, we reject the null when the p-value is less than alpha. So alpha is just a bar we set. And we say, here's where I want to put alpha. And since our p-value is below alpha, we reject the null. When the p-value is low, reject the null. So I would say, I reject the null, and I do have evidence for my alternative. There is evidence that it is not equal to, that it's different from. And we should get it right. No, is it really the plausible ones? Does anyone see decimal errors on here? Let's see, what did I do? We are definitely rejecting the null. P-value is less than. Well, they're not going to do that. Let me look at the results again. 2.91. No way. I see it. This is a email Brian and get your points back because I think there's only one error. Do you see it? For 5,000 points, you could email me and get your points back. This is like, come on, my Pearson. Come on. I'd be like, really? Do you see it? We didn't get anything wrong, I don't think. There's nothing really wrong. It's the bane of all of our existences, the decimal rounding on Pearson. And we got one other thing wrong. We reject the null. There is evidence to conclude it's different from. And we are doing that. So are they? They're not doing these. That's what I thought. I've done these before. Who sees the other thing? We did plausibly. I think I say it's no way they're saying it's not. That's good. Did I mistype that? I can't read. You have to be kidding me. Okay, do you see it? I know I keep saying, do you see it? 28.77. No way. Wow.
Wow.
Stress. I was off by the tiniest of ever. We all do it. It's one of those days. One of those days. Tiniest. This is the same data right here. Oh, it's the same question. Psh, watch this. We're going to speedrun this question. Let's do this. Little hacker man right here. Let's do this question right fast. Ready? All right, we're going to copy this clip. We're going to bring it over here. We're testing to see if they're different. So we get the null that is equal, get the alternative that's greater than. This condition is plausible. This condition is plausible. So we could be using this right here. We drop the data and jump. Do this. We run the data. We go to analyze. We go to distribution. Drop in the data. We run the data. We go right here. We extract the data. We go to test the mean. We go to 28.3. We got 4.43 as the p. That makes the p-value basically 0. I'm just going to say 0 because it's so tiny. That means we reject the null. We do reject the null. There is evidence that it is different from this. Now we go and we grab this right here. Oh, it's 0.007. 3 decimals. I was close, but it's 0.007 on the decimal alternative. And then we go over here. We enter in the mean. And we just do the mean standard deviation. We're good to go. 28.82. And then standard deviation, 0.2858. 2858. As long as it didn't blur my eyes. Yes. Okay, that's our redemption arc right there. We did it. We got the question right. We just entered everything in the right way. Sometimes when I'm teaching it and going through it, sometimes my brain blinks and then I don't get it right. I feel sad. Every time I get a question wrong, I'm like, what did I do? Should we do the yogurt one too? It's very similar. It's all of these ones here that you can use jump on are the exact same steps. What should we do next? We got time for probably 4 or 5 more questions. You pick it. That was the potato chip question right there. As long as you enter it in jump and enter the decimals right, you should be good. This one's the same steps right here. I wish they went into more detail on random, 10%, and nearly normal condition. But what other questions are there? Could do that one. This one you have to do by hand. This one's a different solve. This one's a solve by hand. Another solve by hand. Yeah, because you don't have jump data. Nulls and alternatives. That's a good practice. I do like that. More nulls and alternatives. Yep, we showed how to do it in jump. We walked through it really slowly on the first solve of it. A solve by hand, let's do that. You're right. Moira's got all those good tips. Okay. This one's pretty interesting. What's the other one? Okay. I like this one. This one tricks students. Yeah, no worries, Dylan. Good questions. Let's show you some points. Okay, you ready? We'll do a solve by hand one here and show how to do this. So 2023, Stat Tool 1, Chapter 15 quiz, and the National Center for Education Statistics. Okay, with this one right here, in 1996, a baseline was used to assess. In 1996, 31% of students reported that their mothers had graduated from college. In 2000, responses from 3,757 students found that 32% had graduated, parents had graduated from college. Is this evidence of a change? Now, that's where usually students make a mistake. Now, what is the first thing we do in Brian's method for solving these hypothesis tests? The first thing we do is we write our what and what. The first thing we do is we write our what and what. What's the first thing we do? We write our what and what. The first thing we do is we write our what and what. It's the hacks method. What's the first thing we do? Who knows? For points in the chat. What's the H? We have to first write our what and what. I'll give you a hint. Evidence of a change is a hint on what we're going to need to do. Also, this value over here, the baseline value, is going to be important. Any guesses? Give it another 10, 20 seconds. Don't worry about being wrong. Just take a guess. What does the H stand for in hacks method? Write out your what and what. That's all right. Dylan, I like that you just said I got nothing. That's fine. I like that you're here. So we have to write out our null and our alternative. To write out the null, the first thing we write is what? When writing out your null, the first thing you write is what? When writing out your null, the first thing you're going to write is what? What are the first two letters you're going to write? When writing out the null, the first thing you're going to write is what? What's the first thing? H-O-H-A, right? So we got to write the H-O-H-A. So that just says the null says, the alternative says. So we write H-O and H-A. And with this now, we are going to go here and note that this is the hypothesized proportion. And then the evidence of a change is we're going to say it's not equal to. Now, this is where, hey, Caitlin, good to see you there. Former students in the chat. Caitlin, good to see you in the chat. The P0 is the hypothesized proportion. And so we put the hypothesized value right here. Whenever you're doing the testing, the hypothesized value goes right there. So make sure to put the value that we think is true. Darius in the chat too. We got everybody. And so we got the hypothesized value. And wait, what do I put right here for the null? Who knows what I put right there for the null? What do I put in that spot of mathematical symbols for the null? The null has the equal sign Nancy jumping in. We got everyone jumping in now. It's like the Avengers. It's like the end game of the Avengers. And I'm like, you can't beat me, problem. And then like people start coming through portals. I'm like, whoa, Caitlin's here and Darius is here and Nancy's here and Dylan's here and Brando's here. Everyone's here. Just like, I need the portal on this screen. I don't have it. And we're testing the proportion. There we go. So we've got the proportion of people who have mother portals opening up everywhere, right? It's just Colin jumps in, DD jumps in. We got everyone jumping in. Can you doing with situations A through D? Yeah, let's do that one next, Kai. You got it. So we've written the null and alternative. And now we have to go here and do the following. We can do the conditions, but those are kind of boring. But watch this. P hat is the sample proportion, which is this. This is what we saw. And there's one last thing I want you to tell me that I haven't marked in the notation. As I write this equation on the bottom, tell me the last notation thing I haven't marked, and then we can actually solve the full thing. There's actually technically two things. I'll give you a freebie one. P0, Q0. I know everyone knows the other one that I haven't marked. I need you to find the other one I haven't marked. Stagnation is symbol. I'll make that a quote here in a moment, Brando. What is the last thing I haven't marked? Sometimes this thing gets to me. The last thing I haven't marked is what? Don't do it. Oh, so I'm going off the screen, that's why. Okay, let's fix it. What is the last notation I haven't marked? N, you got it. Right over here. Okay, this is going to equal z-score. I'll disappear. Stat Nation. I don't feel so good. Okay, there we go. Let's do this. Got snapped away. There we go. And then we just start solving for the z-score. And so it's going to be 0.32, 0.31, square root, yes, that's right, 0.31 times point. That's the complement. P0 and Q0 are complements of each other. They add up to 1. 1 minus P0 equals Q0 complements. And then the sample size 3757. Okay, that's the standard deviation on the bottom. And so let's jump in here. Let's get the z-score. So it's going to be 0.31 times 0.69 divided by 3757, and then square root. And we get 0.32 minus 0.31, which is 0.01, divided by that. The z-score is 1.325. So we go back to our problem, and we enter in the z-statistic right here, and we take a guess at the p-value. Now here's the thing. At a z-score of 1, follow me. Outside is 32, but we're further out, so it's going to be less than 32. Who thinks they understood what I said right there? That, I'll show it visually, but at a z-score of 1, the outside is 32, because 68, 32, but we're further out, so it's going to be less than 32. So you just kind of think, like, what's this going to look like? Well, since we're doing the does not equals test, we have to go to the outside and find the p-value, and we enter in the negative version and the positive version. Remember, we said it's less than 32, because we were at 1, it would be 32, but we're further over on the curve, so it's going to be 0.1835. There's the p-value. Okay, I need your help here. The p-value is what to alpha? The p-value is what are to alpha? I'm going to go back and do the rest of these, and then we're going to do other question. The p-value is what are to alpha? These are the easy ones. The p-value is what are to alpha? The p-value is what are to alpha? Ooh, I think this one might be one of the ones that's actually messed up. Oh, no. Because we got a high p-value. The p-value is higher than alpha. So we do not reject a null. Since the p-value is high, we let the null fly. The p-value is we fail to reject. There is not evidence for the alternative that it is different, that it has changed. We'll do that last one here in a moment. The null was that it is equal to, because null has equal sign, and the alternative was that it's different. We can say that this is plausible randomized. This is, I'd say it's more than plausible that we did less than 10%. And we do have at least 10 successes, at least 10 failures. That one is literally justified in our null hypothesis. We have at least 10 successes, at least 10 failures. I think this one is the one that actually gets confusing because of the way they did this problem. Do you think this difference is meaningful? The difference is probably meaningful because the observed change in the sample is large. No, it's not. It's only 1% difference, so B is wrong. The difference must be meaningful because it is statistically significant. That's not a fact right there. You have to interpret it and think if it is meaningful. The difference is not meaningful because it's not statistically significant. The difference is probably not meaningful. The observed change in the sample is quite small. So even though it is, now here's where I'm going to get mad. If it says I'm wrong down here, I really think this is the question that actually has an error in it. Please email us if you have this error, because what do you notice? Even though it is statistically significant, and my person needs to be contacted on this is literally an error. Was our difference, and good question, Dylan, right there, I'll show that again. Is our difference statistically significant, yes or no? Someone explain this to me. Yes or no, is our difference statistically significant? Yes or no? No. The p-value is not statistically significant. This one, I know this question quite well. Why I wanted to do it too, because in the versions of it that simulates where the p-value is higher than alpha, the question doesn't change. So that is wrong. The difference is not statistically significant. Statistically significant means p-value lower than alpha. And thank you so much right there. Yep. And so the z-score is found via the equation on the screen of p hat minus p naught over p naught times q naught over n. And that gets the z-score right here of z equal to 1.33. So this is how you find the z-score right there. So good stuff. It's hypothesize, annotate notation, check conditions, and then solve and state conclusion. How do you find the p-value? You take the z-score and bring it over to the applet. And on the applet, since we're doing the does not equals test, you enter the outside area and find p-value. Make sure you're using the T for the T and the Z for the Z. Good questions, Dylan. And we got another one. Dylan, drop a question in the test on the chat that you're doing. Can you do this one with situations A through D? So situations, drop a question in. These take practice. These are one of the ones that people are like, I have no idea how to do these. They take practice. We can do it. Situations A through D. Kai, if you see it in the chat, let me know. Situations. Do we see it? Here it is. Given situations, right? Is this correct? Let me know if this is it, Kai. I'll take the note on it. This is a good one. This is a chill one. This looks... It's not this one? Okay. Is it this one? Casino? Yeah, I think it's this one. Cool. When you see how to do these, you'll be like, no way. No way. You're welcome. Thank you, Kai, for being here. The situation. Remember, office hours, swing by, ask your questions, and we'll do them. Okay, so drop a few more, and we got time for like probably 2 more after this at least. A casino wants to know if their slot machine really delivers 3 out of 100 wins. Now, is there a mean for casino wins or a proportion of casino wins? You go to the casino, would you say my mean wins, which there is if you think about money, but this isn't money. This is how often you win. So is this proportions or means? Proportions or means? It's proportions. Dylan, great job right there. So Dylan, every time I say your name, Dylan, I think about Dylan Schwarzenegger, and he did the Predator. You had to see the movie. But here we go. We're going to put P for proportion, the true proportion, proportion. Look at how many questions we just got right. Now the null has the what sign? 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 This is the null. The true proportion is what? The null has the what sign? The null has the what sign? The equals. So you know what we can do? Just go down here and go equals. We don't have to think through those. The null has the equal sign. The only thing that changes between the null and alternative is the alternative has a different sign. So you just put equals for all those. So if you notice, once we know it's P, it's proportion. It'll never be P hat and it'll never be X bar. So you only have 2 choices, P or mu for this. And then I think people are already saying it. The alternative is it really 3 out of 100 or is it not 3 out? How do we pick the sign of the alternative? How do we pick the sign of the alternative? Picking the sign of the alternative is based on the what? There's hints on the screen. The sign of the alternative will always be based on what? The data or the researcher's question? The context of the problem. What are they wondering? What are they trying to figure out? What are they trying to understand? So they want to know if it really is 3 out of 100. So it's either 3 out of 100 or it's not. The next one deals with money. Does that sound quantitative or proportions? Like the proportion of money or the average amount of money? What does it sound like? And it almost says right here, if the mean has changed. Like that's mean. So we go right here and we put mu for mean, mu. And they want to know if it's changed. Now be careful, I don't know if it always says changed, so you got to look what yours says. What do I put for has it changed? For has it changed, I should put in the what sign. For has it changed, I should put in the what sign. So they're wondering, has it changed from the amount it was? So the null is that it is that amount. The alternative is that the true mean is not equal to that amount. The next one deals with a cure rate of a drug. Is it the mean of people cured or the proportion of people cured? Just type M or P if you want in the chat. Is it the mean of people cured or the proportion of people cured? It'd be P for proportion. So we go here and we put in proportion. That's what we're doing. And now we just have to ask, they want to know if it's lower. So what sign should I put in here? They're asking, is there evidence that the new drug has a lower cure rate? So they say they want to know, does it have a lower cure rate? Wonders if it's less than the current. Yep, that's it. Just look to the question. Next one says the bank wants to know if the percentage of customers using their website has increased. Is using the website a categorical proportion? People might already be on the next one, proportion. Yeah, it's the proportion of people who use the website. And I think who feels like, wow, this question is like way easier. I know it's got like a billion blanks. As long as you don't misclick, and they want to know if it's increased. So they're going to ask, has it gone up? And we've done it. If I got something wrong, I'd be really sad. But I hope like you see a question like, that's easy. You just have to know, like, you have to figure out, all you figure out is how to write the null. Because if you write the null, all you have to do is change the sign. The null just has the equal sign, and then you change the sign to whatever you're testing. You don't run all 3 alternatives, but you pick the alternative based on what you were trying to see if it's true out there. Same thing for this. I guess we could do these, I don't know, not hard. The null has the equal sign. So these are freebie questions. So the null has the equal sign, the null has the equal sign, the null has the equal sign. That's what we're testing. Certain states, 72% of people, CPL compliance. That's the proportion. They want to know if it's changed. So has it changed? Survey found 43% of people are willing to pay on time or something. So that's proportion of people paying on time. Has it changed? Default rate, that's defaulting on your credit card. That's the proportion of people who default, like the proportion of people who don't pay. Is it lower for this group? That's going to be less than. Regular credit cards average this, so that's mu because it takes on average this to do this. They want to know if it takes less time, so that's going to be on average it takes less time for this group, and that should do it. There we go. Like I said, I like those questions. They're really good. If you know how to do them, you know how to read what you're looking for. Will be an appropriate alternative. They want to see if it's a higher cost, so the true mean is greater than that. Look at all. There's not too many. The ones towards the end are more difficult. They want to see a student on tracking wants to test if miles terms are different. So they want to see if they're different. The alternative is just based on whatever they're asking. Ooh. In a criminal trial, one option is to declare the defendant not guilty. In a hypothesis test, what would be your conclusion? A, B, C, or D. Type A, B, C, or D in the chat. Would it be to reject the null, fail to reject the null, accept the null? If you're not guilty, and you walk in not guilty. So when you go into a court, I'll put this one in the notes, and then drop more questions. We've got time for another big one if you'll want. Yep, fail to reject. Is there a bad word on this screen right now? We do not say accept the null unless we're saying we do not say accept the null. Then we can say that. In all other instances, we don't say it. So accept, Meatbot's going to get mad. He's going to get big mad in the chat. So with this right here, the null is not guilty. So they're going to bring evidence. And if they bring evidence, they're going to say you are guilty. But due to them failing to bring evidence, they are going to retain the null. That's another way to say it. And we are going to not reject it. Retain means to stay with. And so we're going to fail to reject the null right here. There's got to be a few more questions, right? We did some of the hard ones. I'm trying to think if we've done a version of this that shows you how to do that. This is just like the other one we did with the proportions. Drop another question in the chat. We've done most of that's the same question, but different version. We did this. We've done that. Drop this quick. Who has another question? Has anyone completed the assignment already and got 100? You're like, this isn't so bad. It's only a few concepts. That's like my theme. This isn't so bad. Which of the following is a correct? So if the p-value is not very small, I wish they just said large p-value. I wish they said, still working on the education one? Good work, Dylan. If they just said we saw a high p-value, that means we saw something that was unlikely or likely. They should just say, if you get a high p-value, what does that mean? Did you see a likely result or unlikely result? High p-value. If you saw a high p-value, you saw what result? If the p-value was very high. Like this. This is your friend says that they can bench 135. And then they bench 136. You're like, well, that was likely. Good job call right there. You'd be like, I mean, would you reject that that's not the right p-value on the screen for that. And I guess technically you'd want to do a less than if you're really saying, I don't know if you, or you might do it different then. If they bench 136, it might be about there. And the p-value is going to be super large because your friend's like, I can bench 135 and you put 136 because plates do have different weights to them. And you're like, oh, you benched 136. And you'd be like, well, that's kind of what is expected or likely. So a high p-value would not be surprising. We saw something that is not surprising. We would not reject the null. And that's just the way it would work. If your friend says they can bench 135 and they bench 136, you'd be like, well, it's kind of what I expected from you. You benched what you said you could bench, so I'm not going to reject the null and stay with it. Reject the null if the p-value is low. That was an easy one. The probability of seeing something or something more extreme that given the null is true is a p-value. Any more questions? We didn't do 5 of them. How about we do one more of these? Someone pick 13, 14, 15, 17, 18, or 21. The later ones are more like a solve. We did a jump problem. We did a solve by hand problem. Or you can say jump problem, solve by hand problem, theory problem. We don't have time for all of them. We have time for one more. What should we do? You pick a number. Pick a number or what do you think? Or I'll pick one in like 20 seconds. 21. This one is another jump problem. Let's do it. This one is tough without jump, but you'll see how it's easy using jump. And that's because statistical software makes everything way easier. Chapter 15, quiz, a consumer group. So with this right here, we have 11 brands of yogurt, and we're looking at how many calories are in each serving. And they claim apparently every brand is claiming 120. A diet guide claims you'll get 120 calories. Weird diet guide being like, try all 11 brands. I hate that they do this with the conditions. If you set up a proper experiment, you should take a random sample of yogurts. You'd know it's satisfied. Your 11 yogurts are probably way less than 10% of all yogurts. And we can see if the data is kind of normal. And so let's look right here. I would say has not been violated. That one's caught me before. That means we're fine. We have not violated the independence condition, which means we took random yogurts. The nearly normal condition is plausible, and we'll look at that here in a moment. Thus, we can use it. So here we go looking at the data. First, copy to clipboard. Now hit Control-C or Command-C. You've copied the data. With the data now copied, we're going to go over here to jump and go to File, New Data Table. Go ahead and paste the data in with Command V or Control V. Now we're going to go to Analyze, Distribution. Analyze, Distribution. And double-click column 1. Go ahead and click OK. We're going to stack it right here. If you notice, it's kind of normal-ish. I know it's a little weird, right skew. Not too crazy. If we do a QQ plot for normality, normal quantile plot, it actually looks pretty good. It follows the line. So overall, a little weird, but follows the line, looks pretty normal. And that's because the bins can be deceptive, because depending on how you bin it, it might look different. A little bit of a right skew. We could even test that. These are all not required. But you could test the skewness here by just going and grabbing the skewness. It's probably going to be slightly positive. It is. But that's only a little bit. 0 means perfectly symmetric. So overall, I would say that that is plausible, that it's nearly normal. It's not too weird. And our sample size is not too large, but it's not too weird. So large enough n comes into play, central limit theorem. Write out the appropriate null hypothesis. Are we going to see P or mu in this? We're looking at the calories. Are we going to see type P or M? Is it, when I click on this, is it going to have P or M in here? Because they're claiming 120. Is it going to have P or M? Because we're claiming 120 calories. Is it going to be P or M? So remember, the claim, the mu naught, well, that kind of goes away, is 120. And so we're going to see mu equals 120. And we're seeing if it's not true, I think. So we're going to say mu not equal 120. And let's see if we're testing not equal to. Yeah, we're just testing their claim to see if it's true. So it's going to be the true mean calories is 120. The alternative is the true mean calories is not 120. And now we can run the test. It's very simple inside of Jump. You just go here and type, you go over here and do t-test for the mean and type 120. Now, before we hit enter, for 5,000 points, I want you to look. Do you think you'll reject 120 and why? What am I pointing out to you? Do you think you'll reject 120? And why? Just type yes or no. 120. Do you think you'll reject it? This is a review from today's lecture. Just look over there. I am 95% confident. No. Because it's in the interval. You notice how it's like a little bit towards the edge? Take a guess of the p-value. I'd like for you to guess the p-value now because it's not smack dab in the center of the interval, but it's a little bit towards the edge. So what do you think the p-value will be? Take a guess of the p-value because if it's right on the edge, it'd be exactly 0.5 or 5%. So what do you think the p-value will be? Because it's not smack dab in the middle like the most likely thing. It's in it, but it's a little towards the edge. I want to see what you guess. One guess in the chat. I owe you points. So what's your one guess? I like it. Give me 2 decimal places. Give me 2 decimal places, Jackson. I'll keep 3 points. 2 decimal place guess. I want to see if you guess what I guess. Oh, you said 0.06. I see the guess over there on the 0.06. I think 0.07. Let's see. It's a little bit higher still. It's 0.108. We were right. I mean, it's a little bit higher. Good guess, Kaya. Kaya got the closest, another 5,000 points. The further towards the edges it is, the less believable it is. And once it leaves the interval, it would go below the 0.05 standard on the two-tailed test. No, good guess. I should have gone a little bit higher. I thought 0.07. Kaya had the best guess at 0.08. The answer is 0.108. That's what we're thinking. And the t-statistic is 1.765. So 1.77. And then this is... And so think about this. Is this p-value higher than alpha? Is this p-value higher than alpha? Yes or no? Just yes or no. Is my p-value high? Is the p-value high or than alpha? P-value higher than alpha. Yes, the p-value is higher than alpha. I'm trying to get nice and neat on here. So that means we do not reject the null. There is not evidence that it is different. And on a high note, yay, we did it. Who feels like they're starting to get these a little bit more? Does anyone feel like, okay, p-value is high, just let the null fly? Great job on the points right there. Put the exclamation mark first. Kai right there. Great job, Kai. I could tell. And the other ones are just like solved by hand problems where they're like the previous one we did. These are like the National Center for Education Statistics. I understand it now. Nice. Yeah, these are just like you have to run the test by hand and get the p-value. The jump ones are way quick. Like, here, I'll try to do one of these really, really quick here. Okay, so we are trying to see. I'll mark it. And then I'm going to go do in-person office hours. Okay, let's try to do this really quick. You ready? So if I do it, I'll mark it. Okay, this is a speed run of this question. How fast can Brian do it? We'll get the time even with the question being marked. A company is criticized. Okay, criticized. I'm taking long to spell the word. Okay. Because only 15 out of 49 of its executives are women, the company explains that though its proportion is lower, it might wish, it's not surprising given that 39% of its employees are women. The company looks at 500 executives worldwide, tests the hypothesis. So they're trying to show evidence that the proportion is too low. So that's the one. The null is that it's equal. Do the test statistic right here. So we have to go right here. And we have to do the following. I'll just grab off the screen. I have this question. Good job. So we have to do p hat minus p naught over p naught times q naught over n square root of that quantity equals the z. And so this is p naught because that's what we're testing. P naught is 0.39 and q naught is thus then 0.61 and p hat is going to be x over n with this being x, this being n. 15 over 49, that's going to be a little bit bigger than 31% or 31ish percent. What's the next decimal? 0.3 something. 0.3061. And so now we just start plugging in the numbers. 0.3061 minus 0.39 over 0.39 times 0.61 over 49. We do have 10 successes. Well, it'd be according to the null also. That's good. And let's solve this. I'm going to keep that. 0.39 times 0.61 divided by 0.49. And there we goes that. 0.3061 minus 0.39. And the z-square is negative 1.204. Negative 1.2041. And we can copy that. And there's the z-score. The p-value, I wish I could guess it. Oh, 2, 0. That's good. P-value is going to be... Gosh, come on, quick. It's going to be like 20... Let's find out. Go to the z. Below. Negative 20. Wow, I was way off because I didn't do the curve right. 115. Oh, I doubled it. That's what I did in my head. The p-value is high, so we can't reject the null. Since the p-value is high, we fail to reject the null. That is, the not show is less than. I think we did it. Got it. We did that in a little over 2 minutes. Yeah, Canvas quiz tomorrow. You bet. When's it due? We're gonna head over to in-person office hours here. Pretty tired. P-value was higher than 0.05 alpha, which is assumed unless otherwise stated. So P-value of 0.115 is higher than the 0.05 alpha. And do realize a really good thing to do is be able to write this out. You're a Milton? Wait, did you get it? Wait. Oh, you're there. Okay, wait, Jackson. I get it. There's Milton Scholars Art Department. Oh, wait, if anyone's over there, you say Brian will be there in just a moment. He's going to grab one of his Red Bulls, even though he shouldn't. And he's going to do that. Until then, bye for now, everyone. Bye.